So lesson 2.5, part 2, scientific notation. We were doing standard to scientific yesterday. So now we're going to move and do just the opposite. We're going to do scientific to standard. So in other words, from our notes from yesterday, we're going to start here and move over there. All right. So in order to do that, it says to write numbers from scientific notation to standard notation, you move the decimal the same amount of times as the exponent. Positive, please write this down, exponents move right. And negative exponents move left. So positive exponents move right. Let's put those in green. And negative exponents move left. Let's put those in blue. So positive exponents move right. Negative exponents move left. So here we go. Number 1. Oops. Let me erase that. I thought I had hit the pen, but not hard enough apparently. 4 times 10 to the 4th power. 4 times 10 to the 4th power. So move the decimal the same amount of times as the exponent. So you're going to take this number. If you can't see your decimal, you know it's at the end. So this is really 4 decimal point. Then what you are going to do is, it says it's a positive exponent, which is 4. So I'm going to move the decimal 4 times to the right. So here's the decimal. I'm going to move it 4 times to the right. 1, 2, 3, 4. Now there's nothing to move it around, but I still make those empty little spots. My decimal point is going to go down here now because I'm moving the decimal point. And in those empty little holes, we're going to put zeros. So this answer would be 4 and then 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, or otherwise known as 40,000. The decimal point is at the end now. You can certainly put it, although you do not have to. And 4 times 10 to the 4th power is 40,000. So here we go. Number 2. 3.62 times 10 to the 5th power. 3.62 times 10 to the 5th power. So again, another positive exponent. So you're going to take the number, which was 3.62, and this time we're going to move it 5 times to the right. So 1, 2, this time I had some numbers to move it around, so I moved it twice, and then 3, 4, and 5. And then my decimal point would go at the end. In those empty spots, I put zeros. So my answer would be 362,000. Now the decimal point is, of course, at the end. I could throw in a comma to make it easier to read, 362,000. Now, do not get in the habit. Like this one was to the 4th power and it had 4 zeros. This one was to the 5th power. Did it have 5 zeros? No, because that's not what it refers to. It means move the decimal 5 times. All right, so how about number 3? 8.3 times 10 to the 3rd power. So again, take your number, which is 8.3. It's a positive exponent, so I'm going to move the decimal 3 times to the right. 1, 2, 3. I move it around one number, and then I throw in some zeros. So my answer would be 8300. The decimal point's now at the end, or otherwise known as 8,300. Okay, so number 4, what if I have this? 9 times 10 to the negative 3rd. So now this negative is where it screams to me, to the left, to the left. That means move it to the left. So keep that in mind. That negative, when you see it, means move it to the left. So I write my number, which is 9. If I can't see my decimal, it's always at the end. And now I'm going to move it 3 times. So 1, but going to the left this time. 2, 3. So now my new decimal point is here. I put in 2 zeros as placeholders. So my answer would be decimal point 009. Now the decimal point moved from its old location, which was right here, to its new location. So you want to put it in the front, or that's otherwise known as 9 thousandths. Here we go, number 5. 1.87 times 10 to the negative 6th power. 1.87 times 10 to the negative 6th power. So once again, it's a negative. So of course this negative to me screams left, left, move it left. So I take my number 1.87 and I move it left 6 times. 1, 2, 3, 4, 5, and 6. So my decimal points here, I throw in zeros in all those placeholders. So it would be decimal point. Then I had 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros, a 1, an 8, and a 7. You've moved your decimal point, so it's no longer between the 1 and the 8. It's at the beginning. And you have to include the 8 and 7. Don't forget, don't drop it off. One more. 8.72 times 10 to the negative 4th. Hopefully you were like, oh yeah, left, left, move it left. So my number is 8.72. I move it to the left 4 times. 1, 2, 3, 4. Decimal point. Put zeros in for placeholders. So my answer would be decimal point 0.000872. Remember to remove it from its old location. It's at the new location now. And that is how you move it from scientific to standard. All right. So right here, I got a question for you. Explain why 12.3 times 10 to the 4th power is not scientific notation. Do you notice? Did you see? Did you pick up on it? I'm going to highlight it in yellow because up on the last page we highlighted in yellow too. Do you notice that? What's wrong with that? Well, 12.3 is not a number between 1 and 10. So you would actually say 12.3 is not a number between 1 and 10. Now, you have to be specific. You can't say, it's just not a number between 1 and 10. Because if you don't know anything about this, you would say, well, 4 is between 1 and 10. What do you mean it's not between 1 and 10? Okay, or there's a times 10. I don't know. Is that kind of be between 1 and 10? So be careful there. You have to have this 12.3. So tell me what's not between 1 and 10. All right, and last but not least, we have to order from least to greatest. Order from least to greatest. So let's turn these all into numbers first. So this first one would be 8.6, and you move it 3 times. 1, 2, 3. So this would be 8,600. Okay, my new decimal point would be down here. 6.41 times 10 to the 4th power. 1, 2, 3, 4. So then I would throw in 2 zeros and it'd be 64100, otherwise known as 64,100. And here, this one's to the 3rd power. So it'd be 3.62, and I move it 3 times to the right. 1, 2, 3. So we're talking 3,620 with 1 zero. Okay, so if we ordered them from least to greatest, it looks like this one here is our smallest. So our smallest would be 3.62 times 10 to the 3rd power. Of course, you start with the original. I'm going to put a semicolon in there to separate them. And then you have 8.6 times 10 to the 3rd. That would go next because 8,600 would be next. And last but not least, semicolon, and I'd have 6.41 times 10 to the 4th. Now, I want you to pay attention to, and let me pick up, let's pick up this fun pink. Pay attention to these exponents on the 10. Look at there. I have a 3, and then a 4. Any significance? What do you think? There definitely is. But now, how do you know the difference between this one and this one? The 4, I get, it goes last because it's bigger. I had to move it 4 times, which makes my number bigger. What about this one? I have a 3 and a 3. How do I know which is first and which is second without having to calculate? Well, look at the number. The first number was 3.62. This is 8.6. What's smaller? Well, 3.62. So if they have the same, you look at the numbers. And technically, you don't have to calculate each of these. All you have to do is look at the exponent on the 10. Look here, look here, look here. And if you have two the same, then look at the number and compare. So, real quick, what if I had 5.6 times 10 to the 4th or 8.32 times 10 to the 4th? So the first thing you look at is the 4's. And what do you notice? Exactly the same. So the second point you're going to do, look at the numbers. I have 5.6, I have 8.32. Which one's smaller? Well, 5.6 is smaller. So if I had to circle the biggest one, you would put a circle around because it's bigger. So use your knowledge of exponents to help you determine which is bigger and which is smaller, or order them from least to greatest. All right. Have a good one.